Now let's start to understand the quantum mechanical model of the atom and the orbitals that our electrons exist in. So we have to talk about Schrodinger. Okay, so Schrodinger was the one that's proposed this quantum mechanical model of the atom. We've got a very simplified version here of the Schrodinger equation. If you look the Schrodinger equation up, it's long, it's complicated, it requires multivariable calculus. If you're a chem major, eventually you'll take physical chemistry and you'll learn to solve the Schrodinger equation, or at least part of it. If you're not a chemistry major and you're not going to be taking physical chemistry, this is all you need to really understand about the Schrodinger equation. Basically, it gives us this quantum mechanical representation. So we get this function here that's a wave function. Okay, so we have some energy and we have this H, and this H is actually supposed to have a little cap on it. It's called a Hamiltonian. And so we get a probability function that represents the likelihood that we're going to find an electron at any given place in the atom or the orbital we're looking at. So when we look at the Bohr model versus the quantum mechanical model, our Bohr model, again, we like it because it gives us these orbits to look at electrons on, okay? It helps us visualize the quantized energy level. So even though we know that electrons do not travel on prescribed orbits like planets do, we know that they do exist in these quantized energy levels. And so the Bohr model still helps us visualize those quantized energy levels. So our Bohr model, we've got our electrons, they're orbiting. Very simple. In our quantum mechanical model, if you look here, there's a whole bunch of dots, little tiny dots. In the center here, I have a stronger cluster of dots. As I go out toward the outer regions of an orbital, my dots get more spaced apart, okay? And so where I have a deeper cluster of dots, that's where I have a higher probability of finding an electron. All right? Now, our orbitals also aren't all the same shape. We have 4 different orbitals that we have identified. We have S, P, D, and F orbitals. S orbitals, they're really easy to draw. They're spherical. I can draw one, even though art is not my strong suit. P orbitals, they look like a dumbbell. I can also draw those. Okay, D orbitals, okay, we get a couple of different types. There's 4 of them that look like a 4-leaf clover, which that looks more like a butterfly than a 4-leaf clover, but you get the picture. And then there's also this dumbbell with a donut, okay? So we get our d orbitals. And then f orbitals are really complex. So we're going to look at each of these different types of orbitals and understand the shape of them in the next several videos.